Hello class and welcome to our next lesson on section 13.3 integrals of trigonometric functions. So I have here a few of the basic trigonometric integrals. I have the integral of the sine of x dx is negative cosine of x plus c. The integral of the cosine of x dx is the sine of x plus c. The integral of the secant squared of x dx is the tangent of x plus c. The integral of the cosecant squared of x dx is the negative cotangent of x plus c. The integral of the secant of x times the tangent of x dx is the secant of x plus c. And the integral of the cosecant of x times the cotangent of x dx is the negative cosecant of x plus c. So, a couple of problems for this, right? So, I have here the integral of the sine of 7x dx. So, per that last slide, right? We only saw an x being the trigonometric function was applied to. But here we have a 7x, not just an x. So in order for us to actually apply this integration, we first need to use a u-substitution. And u should be what I just highlighted in pink, that value of 7x. And the derivative of u, which will just be 7 dx. But the problem though is there's no 7 outside of the sign, so we need to divide by 7. 1/7 du is equal to dx. So now we have our parts for this, right? We have our parts. U being 7x and the derivative of x being 1/7 du. So reapplying those into our integration, this is going to make 1/7 times the integral of the sine of u du. And so what does that become? This makes negative 1/7 times the cosine of u plus c. And reapplying that u substitution, this makes negative 1/7 times the cosine of 7x plus c. My 7 looks horrendous. Let me fix that. There we go. The integral of the sine squared of x times the cosine of x dx. So this is one of those special properties when it comes to these u substitutions. A pretty good candidate would typically be whatever the base function is that's getting raised to a power. In this case, the sine function. It's getting raised to the second power. So automatically that should be a value for u, which it's going to be in this case. U will be the sine of x, and the derivative of u is going to be the cosine of x. Now we have both of those already in the terms of the integration, so we're fine, dandy with that. This just makes the integral of u squared du. And we know from the power rule that that makes 1/3 times u cubed plus c. And reapplying that substitution, this makes 1/3 times the sine cubed of x plus c. And I have two more here. The integral of the sine of x divided by the square root of the cosine of x dx. Right, so for this one, you could tell it from two reasons. Number one, it's in the denominator of this fraction. Number one, and number two is the quantity being raised to a power. In this case, to the 1/2 power. That being this cosine of x down here. So u is going to be the cosine of x, and the derivative of u is going to be negative sine of x dx. There's no negative outside of this function or in the terms of the integration. So we're going to divide by that -1 and move it over. So negative du is the sine of x dx. So applying this makes negative integral of 1 over u to the 1/2 du. And applying the power rule to find this integration, this one's going to make negative 2 times u to the 1/2 plus c. And since u was the cosine of x, this makes negative 2 times, this will be the square root of the cosine of x plus c. This next one, I have the integral of the secant squared of 12x dx. So despite there being a power, right, from the formulas all the way back over here, we see the secant one here has a power in it, or the secant squared of x. So that should not be the first automatic thought for this one. This one, the u should just be this 12x because, again, there's no typical number being multiplied by the variable within these trigonometric functions. So u should be 12x. The derivative of u is 12 dx. There's no 12 within that, outside of the trigonometric function. So divide by 12. This will make 1/12 times the derivative of u is dx. So applying this, 1/12 times the integral of the secant squared of u du. And that makes, for this one, 1/12 times the tangent of u plus c. And reapplying the substitution, this is 1/12 times the tangent of 12x plus c. So from those formulas from before, we were missing two. The integral of the tangent of x dx is the negative natural log of the absolute value of the cosine of x plus c. And the integral of the cotangent of x dx is the natural log of the absolute value of the sine of x plus c. And so, two examples here of those. This first one, the integral of the tangent of 6x dx. Since, again, due to that number being multiplied by the x, the 6x is going to be the u for this one. So u is 6x. Derivative of u is 6 dx. There's no 6 outside of the function, so we're going to divide by that 6. This is 1/6 du is equal to dx. And applying this, this makes 1/6 times the integral of the tangent of u du. So applying the formula, this is going to make negative 1/6 times the natural log of the absolute value of the cosine of u plus c. And we know that the u is that 6x, so negative 1/6 times the natural log of the absolute value of the cosine of 6x plus c. And this one underneath it, the integral of the cotangent of 5x dx. So the 5x again will be our u, and the derivative of 5x, so du, just be 5 dx. Again, there's no 5, so divide by the 5. This makes 1/5 du is dx. So this makes 1/5 times the integral of the cotangent of u du. So applying that formula, this makes 1/5 times the natural log of the absolute value of the sine of u plus c. And reapplying that, this makes 1/5 times that natural log of the absolute value of the sine of 5x plus c. Let me know if any of you have any questions or concerns. Thank you.